Page 179, exponents and exponential functions. So again, I think that we covered the pretty good meat and potatoes of math over the past 7 weeks.
Yeah.
But I think you're going to be like, okay, I get this. All right, so these are basically the rules of exponents. Now, just know this. You have seen a couple of them before. We've seen this type of rule. And we might have seen this rule a little bit. It might have been spoken about briefly. But today, we're going to focus on this rule and this rule. Okay? So they are pretty straightforward. They are pretty easy as long as you can remember the rules. Okay? And they're not hard rules to remember. They're just rules. So let's move up. Let's see. So again, we're going to cover those two rules. And not going to worry about that. We're going to go to this screen. Okay. So let's label a couple of things. Those x's are called bases. And these are called exponents.
Is every exponent a base, or does it have to have?
It's just whatever would be the bottom number would become a base. And they don't have to be the same. You can have different bases, but there's rules when they are the same base. So if I have same bases multiplied, then add exponents. Okay? So I have the same bases. So this is going to yield me an answer of x to the, if I add the exponents, I get what? 7. Problem's done. Okay? So I'm going to start out a little sarcastic comment, and then I will finish it in a moment. Exponents are like bunnies. The little rabbits that are showing up in all of our yards? When they're all on our yard, all just eating grass, they're on the same level thing eating grass, you can count them up and say, oh, look, there's 7 bunnies out front. Does that make sense? All right. So the second rule, this is called power to a power. And what this basically means is you have this 3 times. And then you can go back to the rule we just said, is if we have like bases that are being multiplied, you add the exponents, so you get 2, 4, 6. Which means these exponents get multiplied. So, again, I go back to my sarcastic joke. When you have bunnies all over your front yard, and they're all eating the grass, you count them up. So exponents are like bunnies. When they're on the grass, you just count them up. You add them up. But when they are on top of each other, they... Oh, there's your biology lesson for the day. So... Johnny's loving this.
Johnny, tell me what it is. Tell me what it is, Johnny. You never laugh like this.
Because he understood my joke.
I don't understand you don't. How do you know?
Exponents are like bunnies. When they are on the grass, eating grass, you add them up. When they're on top of each other, they multiply.
Okay.
No, they really do. So there's your cross-curricular activity for the day. A little anatomy, biology, and math. All right, so would you turn to page 181 now? Page 181. And we're going to incorporate those 2 rules. We're going to take a look at problem number 1. All right. So, hey, friends, shh. What are my bases on that problem number 1? 2. What are my exponents?
3.
Are these being multiplied?
Yes.
So I get 2 raised to the 5th. And I guess you could go 2 times 2 times 2 times 2 times 2 to get 32. But this right now is fine.
Wait, what if you multiply the 2 and just add?
You do not multiply the bases. You just keep the base the same and add the exponents up.
This is
Okay.
like addition.
So a couple of other things to think about how this is. This is 2 times 2 times 2 times 2 times 2. So how many 2's are there? There's 5 of them. That's why it works.
So what if there's like different bases?
All right, we're getting there. So like number 3. First off, number 3, we are adding these together. Agree?
Wouldn't that be 7?
So what's 3 squared?
9.
9. And what's 4 squared? And if I add 9 and 16 together, I get 25.
Oh, so you use the exponents as a plus.
Great. Math should be like this all the time.
I'm doing what I can for you. Told you it's a breath of fresh air.
I can breathe now.
Yeah,
So if it's a plus or minus equation, would it be, you
just do the,
square root?
use, no square roots are needed.
But I mean, like you,
Just do the exponent.
So we don't use it square powers?
Yep. Right, it's done.
Why don't we do that with these?
I think it's how we.
The first one, you are multiplying the bases. Like bases being multiplied, you add the exponents. The second one is unlike bases, and we're also adding them. All right, so I have number 5 and 6 written there. Notice, what's the difference do you see between number 5 and number 6?
One and then I got-
Parentheses. So, hey friends, you remember in the quadratic formula when we had the b squared minus 4ac underneath the radical sign? And I said b squared is always positive, right? Good. So this is where this kicks in. Okay? So, if I were to take negative 6 and square it, I get positive 36. But if 6 is negative and it's not grouped, take a look at the answer.
It's negative.
Right. So that's the reason that underneath the quadratic, when we had b squared, I said it's always positive, because that's a big time error that people make. So when you are dealing with exponents and you're able to get a numerical value, if it happens to be negative, if it's grouped, it's going to be positive. If it's not grouped, it's going to be negative.
So 5 would be 36 and then 6 would be negative.
You got that right.
Yeah, you add a negative at the end.
Well, no, number 4. We didn't do number 4.
Well, you'll get there. You can do that on your own in a little bit.
So do we really just write 36 and then negative 36?
That's exactly right.
Sure.
Yeah. Hey, well, my turn to watch him. So I'm not sure where he's at. I mean, if he's not next door in the office, I don't know where he's at. So, sorry, Jan. All right, so the big thing to remember with this one is grouped, and it results in a positive answer. This one is not grouped, and it results in a negative answer. Okay? That's a big, oh, okay, I get it.
Oh, yeah.
Okay? Yeah. No? Question?
So basically for the dot group, you just do the equation, but then you just add a negative then?
Yep. Okay. So that's the big key on that page. What page are we on? 181? Yeah.
5,299,000.
We are on 181. I think. 3. 1. 3. 3.
Page 3.
We are on page 180.
Shit, what
Are you ever gonna take the LL?
about, like, won't come up? It was just like, let's try to wait sometimes.
There it is.
All right. Let's move on. All right. So let's get to a problem that looks a little bit different, but I think with some critical thinking, we might be able to figure this out.
7.
So we're trying to figure out what n is equal to. So now we have to think, okay, 10 to the first is just 10. 10 to the second is 10 times 10, which is 100. 10 to the third is 1,000, because that's 10 times 10 times 10. And then 10 to the fourth is 10,000, and you can keep going and going and going. All right, so what, in this case, looking what we have to the right, what does n have to equal? 3.
So if you have tissues anywhere,
You just run to the restroom.
be right back then.
Goodbye, Gabe. Not fall.
All right, then problem number 9, we have 2y raised to, or 2 raised to the y is equal to 64. So again, I'm going to do the same rule. I'm going to go 2 to the first is equal to 2. 2 to the second is equal to 4. 2 to the third is equal to 2 times 2 is 4. 4 times 2 is 8. 2 to the fourth is now equal to 16. 2 to the fifth is equal to 32. 2 to the sixth is equal to 64. So y equals what? 6. Okay, do you understand how I'm making those lists? I'm not memorizing them. I just kind of know that 2 by itself is 2. 2 to the second is 4. 2 to the third is 2 times 2 times 2, which is pretty easy to do.
So it'll be 2 times 2 times 2 times 2.
Mhm. Still, breath of fresh air? Cool. All right, can I go to number 11? All right, number 11. See if we can incorporate what we just learned. What is this one going to be? Y to the 8th. Yep, you add the exponents. It's done. Number 13, I have c to the 6th. And if c is sitting alone, what number is c raised to? So what's this answer? C to the 7th. Good.
It's a very nice seat. Thank you.
I'll do what I can. Every now and then I get lucky. All right, this one is power to power. It's like bunnies. So what do?
We multiply.
Multiply. So I get x to the 12. Okay, number 17 is another power to a power. Yeah, but it's negative. Okay, well, let's incorporate our rules. Power to a power, what do I do with the exponents? Multiply. So if I multiply, negative 2 times negative 3 is positive 6.
We're gonna write a negative.
I caught myself. But you see my error. Number 19, I have 3x to the 4th times 8x to the 6th. Okay, so this one looks a little different. So let's kind of think a little bit about this. I know that I'm going to wind up with x to the 10th. Are you good so far? Friends, what do you think we should do with the 3 and the 8 now?
Multiply that.
Yeah, 3 times 8 is?
24.
24x to the 10th is our answer. Feeling okay about this so far?
24
X to the 10th, yeah. Number 21. Let's see if we can use our same skills that we're just seeing, trying to bring them together a little bit. Okay, so let's take care of the exponents first. 4 added to negative 6. Negative 2, very good. Negative 2 added to 7. Positive what? Positive 5, yeah. Do you feel comfortable with what I've done so far? Now we're going to go ahead and multiply negative 3 times 5. Negative 3 times 5 is? Negative 15. Negative 15 times 2? Negative 30. Negative 30, x to the 5th. That's my answer.
Hold on, what do we do with the negative 3 positive 5 here too?
Multiplied. I multiplied here to get negative 15. And then I took negative 15 times 2 to get negative 30.
So I was like,
I'm so smart. I did. Everyone.
number 23.
Number 23. So it looks like we're multiplying some bases together. And if they're a like base, we add the exponent. So if I take care of the x's, what do I get? X to the 7th. If I take care of the y's, I get y to the 5. Done.
Oh, wait. Oh. Sorry.
Then number 25. I got something grouped.
So you add a 5x4, right?
So hang on, let's see. Let me get it written down before we start. Okay, so my friends, how many of these do I have?
4.
How many of these inside the parentheses do I have?
2.
2. So this is 5x squared times 5x squared, and then times 2 times x to the 6th. Okay, so this yields me this. Okay? All right, so let's do the exponents first. If I add those all up, what do I get?
5x1.
X raised to the 10th power. Okay. All right. So then let's multiply 5 times 5, I get 25. 25 times 2, I get? So 50x to the 10th.
I just really wanted dx4.
Cool. So a few things just to note. This thought process of math has something to do with something that we all like.
Pizza.
We like that too, but in order to buy pizza, we need money.
Oh wait, that's right.
Okay? Now, I'm going to throughout this chapter, I'm going to be talking about some real life applications of math. Okay? Real world math. Now, I'm going to pull up something on the calculator. You do not need to know how to do this at this point. Okay? But can I take us on a little adventure?
Do I have to take notes?
Nope, just watch. Okay, I'm using something called the TVM solver. Don't worry about what I have in there right now. So let's talk about this. I want you to think about this from starting at age 20, going until age 60, 20 to 60, we're talking about 40 years. Agree? And there happens to be 12 months in a year. Do you agree?
Yeah. Just so happy.
Now, I'm gonna start there. So that means we're talking about 480 months. Now, this poster right back here, the very back,
Which one?
right here, this is up to 2018. Okay, this is basically the stock market.
Okay.
Okay. Now, how the stock market works, if you look at the U.S. stocks as a whole have grown from up until 2018 to from 1925 to 2018. Have grown at a rate of averaging 10%.
Every year?
Well, the problem is some years dip, right? COVID had a dip, 2008 had a dip, 1995 had a dip,
Actually, I know.
1982 had a dip. I mean, there's some dips that do take place, but longevity, what you all have, if you start this starting at age 20, and you do this every month until age 60, so 40 years. 40 years seems like a long time, and I realize as a teenager, you're like, I don't want to think about it. Okay, but hang on. So let's go real conservative. I know I said 10%, but let's go real conservative, saying 8%. Okay? I start with a previous value when I'm at age 20 of $0. And starting each month at age 20, each month, starting at age 20, we're going to put $200 into a mutual fund or some sort of stock index fund. Okay, this is not your typical savings account that's in the bank. Savings account in the bank earns you about 0.3% interest. Okay, now, friends, the greatest thing about a mutual fund, we right now are probably not billionaires. But how do the billionaires continue to make more and more money? They invest more and more money. So you are going to play in the same market as the billionaires play in. A billionaire wants more money. A millionaire wants more money. Okay, so we are saving now. We are saving now for 40 years. So we're going to be putting $200 a month starting at age 20 until we are 60 years old away. Anybody want to take kind of an educated guess at what we'll be at? How much? So, friends, do you think this is 100,000, 500,000, million, 2 million, 10 million? What do you think? You think it's going to be? So I'm going to make 480 equal payments of $200 each. You think about $1 million? All right. So, okay. And you're earning interest because your money is now being part of the buying power of large corporations that are making billions of dollars a year. Okay? Ready? So you think it's going to be close to $1 million? All right. Alpha, enter. You, at this point, would have $698,201. Okay? So someone do me a favor. Write down that number, 698,201. Don't worry about the decimal. 698,201. You have it written down?
I got it too.
Okay. So quit. So we said we're going to invest $200 a month, and we're going to do 480 months. Okay? So this is how much you're putting in. What was that number you just told me?
698,201.
698,201. Okay? So, my friends, you have invested with 480 equal payments of $200, $96,000 you put into the account. Okay? So that means that your account made in interest $602,201. Interest. Interest is how, when you invest in the stock market, and yes, there's individual stocks, and yes, everyone's going to say, oh, go Bitcoin. I'm not that guy. I am a large cap and mid cap, meaning I'm a large corporation, Amazon, Google, Nike investor, and a mid cap company, so smaller companies such as Whole Foods is a smaller company. Okay? Yes, Whole Foods is huge, I get it, but Whole Foods doesn't make as much money as Amazon. Okay? So I invest in these funds for a reason. Now, you're talking about $602,201 by you investing only $96,000. So your money is worth, well, let's do this. 96000 divided by 698,201. So your money is worth, you made some good choices. You made some really good choices. Now I'm going to go back to my TVM solver. And again, this has to do all with exponents. This math does work. Okay? Yeah.
Isn't interest, isn't that like, do you gain money for like depositing or whatever?
You're putting money in, so corporations get to use your money to make more money, and then they pay you back money as far as interest on your money that you've already invested. Okay? So basically, you, the investor, are becoming a small version of a bank, so a company can borrow against your money to make money to do really, really well. And the reason I always say mutual funds and index funds, those are multiple amounts of companies that are involved in that. If you go with a single stock, like if you say, hey, I'm going to invest in Google, what happens if Google goes bankrupt tomorrow? You're losing money. But if you had an account that had Google and Amazon and Nike and McDonald's and Walgreens and large companies, Walmart, those companies are all going to make big money. And they're going to pay back to the borrower a much higher percent. So in this case, 8%. So watch this now. So from age 60 to age 90. So we're talking about 30 years, and each month, until we're 90, we're going to take our money back from these funds. They're still earning 8%, but now we're drawing away. We are no longer putting money into it, but I'm going to move my future value of 698,201.57 right to the nearest penny. Okay? I want my future value to go down to 0. So now I am going to take money back each month in an equal amount from age 60 to age 90. Formidable, good retirement years. Agreed? So that means this. Alpha, enter. So you are now going to get $5,123.16 a month for the next 30 years. So somebody do me a favor. Write down 5123.16. You have it? Tell me it. 51 what?
5123.16.
And we did 360 equal payments. Agree?
Yeah.
So basically, over the long haul of this loan, you're getting $1.8 million back. Friends, remember the initial investment of $96,000?
Yeah.
When you turn 90 and you get your last check, that original $96,000 resulted in $1,844,337.60 for an initial investment of $96,000, meaning $200 a month from age 20 to age 60. Okay? So think of it this way. Again, this is a very, very cheap way of doing stuff. Okay? So if you take this, that's basically how much you would be taking in a year. Now, this is a very simple way of trying to do it. What happens when you are investing as an adult, as you are making more and more money in your career, you are investing more and more money. So I stayed at the original lump sum of $200. Okay, but your $96,000, you remember your original $96,000? Look what you're getting a year compared to your $96,000. You're getting roughly 2/3 of your money back that you invested in 1 year. And you get that for the next 30 years. Okay, so friends, when you become seniors, there is a class that I teach called Business Calculus. And I want to make sure you take it. Okay, it's a 1-semester course, and it has an awful lot of real-life applications with money, and it talks about loans, and it talks about credit cards, it talks about, you always, all of you have heard people say, oh, I really wish they taught me this kind of stuff in school. Well, I'm telling you a class that I personally, and I'm the only teacher of it, I teach this class for a reason. Okay, and my goal, that $96,000 originally basically pays you out over $1 million from age, you invest $200 each month from 20 to 60. From 60 to 90, you're taking back your money. You're no longer investing. And it's going very far for you.
Why do we have to do 40 years?
Huh?
Why do we have to do 40 years?
Well, most people will retire by age 65. I'm slicing 5 years off that for you.
Hey, nice.
But the time is on your side. That's what you're looking at.
So
The time being on your side is the biggest major growth factor for you to make money.
Haven't you been in the stock market for a long time?
I have been for a very long time.
Something like, what, days?
1988 was when I bought my first index fund. Okay?
Pretty close.
Yeah. So
then you don't get money until you retire?
So I am going to lowball where I should be at. And when I say lowball, it should be a lot more than this. I'm going to lowball it. So I'm going to go back into my apps, lowball it, TBM solver. Okay. I still want the 360 payments. I'm lowballing my net worth. Let me see. Let me get. Okay.
2 million.
So at 80-60, that's where I should be, which means my payment from 60 to 90 is that much a month.
$14,000 a month.
And monthly.
To be at 2 million.
And he's lowballing that.
How many months?
How long did that take you?
360 months from 60 to 90.
So 300 times whatever that number is.
Okay, write that down. Write that down.
Will let you.
14,675.
$2 million.
Okay.
14 what? 675 times the 360 equal payments.
That should be much higher.
Oh.
That number should be a lot.
That's what my payout would be if I lowballed it. I kid you not. I kid you not.
Stirrup's gonna be a billionaire probably.
Okay? So now, friends, here's my moral of the story. Here's something that drives me absolutely crazy about people in society. Oh, you're a teacher. Oh, you're just a teacher. Oh, they don't pay you enough.
You think you're
Teachers
getting a good
don't
pay?
get paid enough, but
Or would you teach? for
Being that I'm lowballing, by the time I'm 60, that I'll have $2 million in net worth assets, and I'm lowballing it, meaning that's a very, very low value.
I think.
Should I complain about what I'm making, being that on that lowball value that I'm going to be getting
$2 million?
$14,000 a month from 60 to 90? So $14,000 a month times 12. That's what I make a year. That's when I retire, as I lowball it. Okay? Friends, I kid you not. This is a real life application and is something that you can do. But the key, again, my friends, is when you are young, if you start disciplining yourself enough when you are young to start saving for the future. Now, someone asked me, what if you don't live to age 90? And what if my wife doesn't live to age 90? Oh, gee, my two daughters get that $14,000 a month until it expires. It's huge money. Okay, this is a friends, I showed you a very simple way to become a millionaire. It all has to do with exponents. It all has to do with having time on your side. This is a really big process that it's not a big secret. A lot of people, you have to know this about if you choose to invest. You are not a knee-jerk reaction type of person. You don't listen to somebody saying, oh, I heard on the radio we should invest in this. You know, I had a buddy of mine that did this, therefore you should. You don't listen to any of that. You get into the large cap stuff. It's easy to do, and it's not something that is a tough thing. So my friends, what I would like for Monday is I wanted to make sure you have page 181 and 182 done, being I did all the odd problems. Page 182 is a nice surprise because it is blank. So have all of that done for Monday. Friends, have a great weekend. Take care of one another.